We will do it as we love to do it, and to say to everybody, Shalom. On behalf of MASHAF, the Israeli Agency for International Cooperation, MATC, MASHAF Center for Agricultural Training, and Israel's Ministry of Agriculture and Rural Development, we are very honored to welcome you all from all over the world, and thank you so much for joining us today. My name is Evelyn Rosenthal, and together with my colleague Galit Aber, we will be managing together this online meeting. I'm sure we have here many friends, MASHAF alumni that have been here in Israel participating in different activities. But for those who do not know us, MASHAF, together with the Ministry of Agriculture, have been cooperating for nearly 65 years, sharing Israel's agricultural knowledge with countries from the 5 continents. Today, we are very happy to launch this series of lectures on challenges and tools of Israel's agricultural sector in response to climate change. I would like to invite, on behalf of the Ministry of Agriculture and Rural Development, Mr. Daniel Werner, Director of the Department of Foreign Relations and International Cooperation, to greet you. Daniel, the mic is yours.
Okay, thank you. It's really a pleasure to be here. So much people from different countries. It's really a pleasure after so much time. It's a very interesting event that connect again between the Ministry of Agriculture and Rural Development and the Ministry of Foreign Affairs. I will try to be very short, very briefly. And as I said, it's a pleasure to me to join you in this series of 3 different professional meetings that we dedicate to addressing the pressing issue of the impact of the climate change on agriculture. At the Ministry of Agriculture and Rural Development, we regard the organization of such events as very important events. Our commitments to the mutual exchange of information and expertise is basically rooted in the very deep significance for the Israeli agriculture sector. We collaborating with various stakeholders, including government agencies, civil society, and the private sector, and together we can identify strategies to enhance the sustainability and resilience of our food system, particularly in the agriculture sector. Israel stands in the forefront of innovation, offering valuable solutions for the sustainable management of the natural resources like water and soil. We take pride in sharing these advancements and insights with the global community. The exchange of ideas we give to others, together, to every one of us, to far from the crucial situation that we live. And of course, through this kind of dialogue, we can take this issue one step forward. I would like to say that we really extend our appreciation to the MASHAF Center of Agricultural Cooperation in the Ministry of Foreign Affairs for this partnership and in this very important effort. Thank you to everyone to be part of this interesting meeting, and I wish us all a fruitful and enriching conference. Thank you, Evelyn, and the floor is yours.
Thank you, Daniel. Hello, everyone. My name is Galit. I'm from the Ministry of Agriculture and Rural Development, and it is my pleasure to invite Mr. Giora Tesler, the Director of MASHAF Center for Agricultural Training, MATC, to give some words on behalf of Mashav and the center. Please, Giora, the floor is yours.
Giora?
Giora, we're waiting to hear some words from you. You're on mute. While we're waiting for Giora to sort out the mic and to hear some words, I would like to share with you that the meeting is recorded. You all received a message when you entered the Zoom meeting. The video will be available on the YouTube channel of MATC and Mashav. And for questions, please, we welcome questions. The questions will be addressed after each lecture. Please use the chat box for your questions, and we will try to answer them as much as we can at the end of each lecture, and if time allows, at the end of both lectures as well. Giora? Okay, so Evelyn, I suggest that we start with the first lecture, and after the first lecture, hopefully we will hear some words from Giora. Will you introduce Ambassador Gideon?
Yeah. So sorry, Giora has some problems. I don't know. Okay. Let's go to this very interesting first lecture, and please let me introduce Ambassador Gideon Bahar. Ambassador Gideon Bahar is Israel's special envoy for climate change and sustainability. In his capacity, he is in charge of Israel's climate foreign policy. As a lecturer at the university, he leads a course on the impact of climate change and international relations. He is a career diplomat within the Ministry of Foreign Affairs since 1994. He has occupied many posts. Among them, he was the head of the Bureau for Africa, the Special Envoy for African Affairs, Director of the Department for Holocaust Remembrance and Combating Anti-Semitism, Ambassador to Senegal, Deputy Director of the Jordan, Syria, and Lebanon Department, and Deputy Head of Israel's diplomatic mission in Tunisia. And we have a big pleasure to invite him to introduce Israel as a country on the front line of climate innovation. Happy to have
Evelyn,
you with
can you
us.
please allow Gideon the mic?
This is the problem. I understand. Gideon, you can open your mic.
Okay.
Wait.
Hello everyone. How are you? It's a real pleasure to be here and to speak with you from all around the world. My presentation is a kind of an opening for this series of lectures. It is about climate innovation in Israel. I can tell you that Israel, because of its geographical circumstances, was forced to develop a lot of innovation in fields like water, agriculture, renewable energies, nature-based solutions, and other innovations that can serve as a model or give us inspiration also in other countries. So in this presentation, I will share with you some of the Israeli most prominent innovations in the field of climate change. And we will be very happy to share all information with you. And we are looking for cooperation between Israel and your countries and your organizations on these matters. Okay, so I think in many of the countries, people have representatives. We have also Israeli embassies or consulates, and so I think it would be great if you can be after the presentations in touch with them. So let me share my presentation. Galit, just confirm that you see it.
Everything okay, Peter?
You see it. And do you see the second slide?
Yeah, it's fine.
Wonderful. So I'll be speaking about 5 areas in which Israel has a very good expertise in the field of climate innovation. Agriculture, of course, water, renewable energies, reforestation or nature-based solutions, alternative proteins. I'll say something about Mashav and mention also regional cooperation. So let us move into the first slide. What do we see here? This is a slide.
Excuse me, sir, your slides are not visible.
Is it so?
We can see them. Does anyone have a problem to see the slides? Because I can see them perfectly.
No, we see them probably is a local problem. Please check your computer.
Okay,
Yes,
continue.
we can
Thank
see
you.
it.
Me too, the same problem.
Okay, please, if somebody has a problem, please write it on the chat, please, so that we can continue with the presentation. Okay, but it looks it's a personal problem. Thank you. Gideon.
Sorry for all the problems, and we will share the presentations later on with you. So I hope you will overcome these difficulties, and if not, you will have a presentation. So on the first slide, what do we see here? We see an index of climate vulnerability. It means how much countries are vulnerable to climate change. It is a combination of how climate change is affecting them and their ability to stand up against climate change. And what do we see here? We see that the countries with the most reddish colors are the countries to be most affected, and not surprisingly, most of them are in the global south, especially Africa, Latin America, Southeast Asia, and the Indian subcontinent. In this slide, we see an example of Israel's climate tech ecosystem. There are over 900 startups in the field of climate innovation in Israel. Israel is a leading force in startups. It has the highest number of startups per capita in the world. And the number of startups that deal with climate innovation is really on the rise. According to the latest report from 2022, 1 out of 6 new startups in Israel was in climate tech or climate innovation. Also, accordingly, finance is coming and reaching startups in the field, and many of these startups are having excellent relationship and cooperation internationally. Actually, they all aim at international cooperation. And as you can see here, it is the startups are being supported by the government, by the academia. Actually, many of them are being developed in the academia, but also by the private sector. In this slide, we see the effect of climate change on agricultural production in the world. It is based on research done by the World Bank. And the more reddish the color is, the more red it is, the more these countries will be affected, and they will see a significant reduction in agricultural productivity unless, and this is very important, it's not an imperative, unless they are able to deal with it and to adapt to the situation and to adopt new ideas, technologies, concepts, and preparedness plan. But again, what do we see here? We see that the countries to be most affected, again, are in the global south. And we see that there are also some areas where there is green light. It means that these areas will be more preferable for agriculture, but it is not necessarily so because big parts of these areas are based on permafrost. They are in the north, and the permafrost is defreezing, and the soil is becoming marsh-like, full of water, and very difficult to, it is very difficult to perform agriculture there. And on the other hand, in Israel, we have a significant ecosystem of startups and mature companies with that deal with agriculture, and the next lecture will be about it, so I will not elaborate on this point. I will just say that please have a look at the bottom right, and you will see drip irrigation. Drip irrigation is probably the most important Israeli invention or innovation. And it was developed in Israel during the 60s, and it is the most efficient way today to irrigate. It can bring the yields up to 50% and save up to 50% of the water compared with flooding or with flood irrigation. So this is only one of the examples. And I think that one of the most important things that we have to do, and I know many of you are from the field of agriculture, so please remember this point. If you take one point from my lecture, please take the following one. Move into irrigated agriculture, okay? Remember that the most important thing is to move from rain-fed irrigation or rain-fed agriculture to irrigated agriculture. This is the most important thing that we can do, especially in dry or semi-dry lands, and even in Europe and North America and in other places. And here we can see the ecosystem of agriculture in Israel. There are more than 500 companies that work in this field. You can see post-harvest, pre-harvest, livestock, amelioration of crop protections, and many, many more things that can be done and improve and increase our resilience and our productivity together. I'm moving now to the second sector in which there is an Israeli excellency, and this is water. Now, what do we see in this slide? We see the projected water stress situation in 2040. Well, actually, we are already there. It's not a faraway future. We are almost there. And again, the more red the color is, the higher the water stress will be. And what do we see here? Again, we see that the countries to be mostly affected by climate change are the countries most populated in the world, okay? And this is not a surprise, okay? It is not a surprise because a high level of populations demand lots of water and they deplete the water resources. So, but the problem remains. Where we need water, we have less water. Now, the water problem is characterized by at least 3 or 4 phenomena. One, there is less water per capita in the world. The second, the quality of the water is deteriorating. We drink more and more polluted water. Thirdly, the access to water is becoming difficult. And because water resources are disappearing, then people have to march or to walk long distances to get water. And another problem is that in many cases there is there is extra water because of floods or torrential rains, and this creates a huge problem, as we can witness also in South Sudan and in other places. And I'm moving now to the third sector in which we have an Israeli strength, and this is the sector of renewable energy. We are talking about different kinds of energies and different kinds of subsectors in that, like energy storage, the development of hydrogen, energy efficiency, the combination of AI, artificial intelligence, and algorithms in the energy sector. Some of the Israeli companies are the biggest in the world and perform big solar fields or big renewable projects abroad in the United States, in Africa, and in other places. All right. I'm moving now to maybe just one word about energy. I'll just say that, for instance, there are alternative ways to store energy in deep sea. There is a possibility to store energy and to use the pressure from the water to keep air in the water, in tanks, and then release it when we need it. We can do it also underground, and this replaces the use of batteries. We have a project like this in Cyprus, where energy is being stored in the water, in the sea. And this is desalination in Israel. Most of the drinking water in Israel is desalinated, and actually 70%. But not only that, but that we treat the water, the wastewater, and use it again for agriculture. So we treat approximately 95% of the sewage water in Israel. This is the highest record in the world, and we reuse it for agriculture. So actually, if you want, there is a kind of a circular water economy in Israel. We start in the sea, desalinate water, move it to the cities, use it there, take all the wastewater, treat it, and reuse it for agriculture. Wastewater accounts for 50% of all the water used in agriculture or for irrigated agriculture in Israel. And because of that, there is agriculture in Israel. And this is something that doesn't demand lots of technology. It's a concept, it's an idea, it's a way how to organize the water sector. And we'll be also happy to share this with your countries. And again, as I said before, we are a leader in wastewater recycling, but also in the prevention of water loss. Israel loses only few percent of its water because of leaks or mistakes or accidents. And every drop of water that you lose because of a leak is a resource that you lost. It's energy that was generated for nothing, and these are also greenhouse gases emissions that were produced for nothing. So if we can save our water and prevent leaks, and it's quite easy, it's not very difficult. It takes awareness, it takes some reorganizing within the system. It can be done. Here we can see an example of another Israeli technology, this time by a company called Nuf. They have invented a way to purify brackish water. If you can see the blue dots here, these are dialysis machines filters, old ones, that after they were used for dialysis, they were reused in these machines and to purify water. And in 2019, maybe some of you remember, there was a huge cyclone in Mozambique, and we have distributed there these kinds of machine. You see the pipe goes into the brackish water, and another one is coming on the other side, and treated water is coming out. This is really excellent, and they have lots of examples. It's only many different sizes of these machines, and some of them are also operated by electricity or diesel or things like that. And these are some examples of the Israeli technology in energy. Above left, you can see an electric lane, the green one. It charges electric vehicles that run on it. It's good for buses or public transportation. It is done in North Tel Aviv today and in some cities in Europe. On the top right, you can see energy storage in concentrated air or air under pressure underground. You can use solar energy during daytime, store the energy and let it go in nighttime. On the right below, you can see a device that produces energy from sea wave, done by a company called EcoWave. It goes up and down, up and down. You can tie it. You can tie the device to docks, to marinas, to ports, etc., and it produces energy exactly where you need it. And the last picture is the biggest solar field in the Negev in Israel. Another point is reforestation in Israel. We have lots of experience, and this is very important because forests today are dying because of the climate. We can see an example of an area, the same area before it was reforested. This is the gray picture, and after it was reforested, and we see good examples. Actually, most of the forests in Israel are man-made, and there is a lot to learn how we can maintain forests in dry conditions, and especially today when climate change and rising temperatures are killing forests everywhere in the world. My last point will be alternative proteins. These are proteins that are produced in a laboratory or in a factory, and they replace livestock. As you know, industrial livestock, and this is very important for me to say it, industrial livestock is a big contributor to emissions, okay, to CO2 emissions, to methane emissions, and the demand for beef, the demand for eggs, for dairy products is only rising, and that's why we deforestate, we kill the forests to create more room for soybeans, for feeds for animals. So if we can replace it with alternative, it will help us, and it will give us a new source of food and increase our food security in the world. And here you can see the ecosystem of startups and in that field. Okay, this is one of my favorite pictures in or slides in this presentation. And the reason is that I can see myself in it, just there in the middle, if you haven't recognized me yet. This was during my tenure as an ambassador to Senegal. I was involved a lot in a TIPA project. The TIPA project was a vast project that introduced a drip irrigation to Senegal, to communities, to schools, to universities, etc. And I can tell you, in my opinion, and when I look backwards in the years that passed and I see that drip irrigation, and I know there is at least one person here, Suleiman from Senegal. He will later on be able to tell us if there is still drip irrigation in Senegal. There is, and more. But when we started the project in Senegal, there was very, very little drip irrigation. And within 5 years, there was a good transformation into drip irrigation in Senegal. Very important. Lastly, the Abraham Accords that gives us an opportunity to cooperate regionally, and we have a good cooperation in climate with our neighbors in the region. So I want to conclude, and we'll move to your questions, that finally it's all in our hands. How we deal with the climate, what answers do we have? It takes innovation and initiative, and believe me, we can do it. Sometimes the climate crisis, biodiversity crisis, and other environmental crises seem very difficult and very difficult to overcome. But I deeply and honestly believe that by cooperating together and sharing information, I'm sure we have a lot to learn from you, and we have to learn from one another. And maybe an outcome of this series of presentation will be the creation of a knowledge community in which we will be able to share ideas between one another. This is the most important way to move forward, and I'm confident that we will come this challenge. So I'm at your disposal now for questions and answers.
Thank you very much, Gideon. For the moment, we have no questions in the chat, but maybe.
Evelyn, if I may, I have a question to Gideon. Gideon, hi. You spoke about alternative protein, and you spoke about innovative technologies and saving water and recycling water and utilizing water. In your opinion and with your experience from Senegal and other countries, in order to implement or assimilate these technologies, what is the main thing or the main factor that the country needs to have in order for them to go forward with the innovations, and the alternative protein? Usually it's very expensive, but you need some kind of motivation, or something has to happen in order for a country and a farmer to be open to use these innovative technologies. So in your opinion, what will be the main factor in order for these technologies to be assimilated?
Okay, so some of the technologies that I have mentioned and shown here are indeed for demand investment and demands budgets, etc. But many of them are not like that. Many of them are very simple. Drip irrigation is very cost effective, very cheap, and can be applied everywhere by almost everyone. Using technologies to harness water, like digging in the ground to stop the water from, just being washed away. This is not a sophisticated technology. I think that the most important thing is one has to understand their challenges, where are their problems, and what do they need in order to overcome them, and then to be aware of the solutions. Okay, now solutions might come from a variety of sources. It's not necessarily that to protect agriculture against climate change that we will use only one method or one idea. We will have to use multiple strategies. And many times, you know, Galit, it's not a question of technology, it's a question of strategy. It's a question of being aware of what's going on to happen. It's a question of having access to the knowledge, to the climatic models that you know how your country, your region will be affected, and then to prepare yourself for that. So all by all, we have to expand our horizons, expand our sources of innovation, inspiration, and knowledge. And then the answers will come. Once we have answers, we will have also the means, we will have also the understanding how we can acquire the means, whether it's finance, whether it's technology, whether it's experts. And you have here Mashab who can help you with expertise transfer.
Thank you. I see we have questions from the participants. Evelyn, you would like to read them out?
Yeah. Let's.
One of the question is, how safe is to manufacture protein?
Well, it is a good question. It is very important. We cannot do it just like that. There is a very strong regulation. I've said that Israel is a leader in the world. We are number 2 in the research and development of alternative proteins. Number 1 is the United States. So far, we have given permission to milk, to alternative milk, a permission to sell, and it's the first company in Israel that receives permission. The others are still going on through the regulation of the Ministry of Health. I know that in Singapore they have given permission for alternative chicken, if I'm not wrong. It takes time, but things are moving, and this is billions worth of market. Countries will definitely move into it. We will have no other choice but supplement part of our calories, part of our nutrition from these sources of alternative proteins, whether it's milk produced by bacteria, like a company that does it in Israel called Remilk, even honey. I've eaten honey made by bacteria. It's real honey, the same taste, everything. And there are companies that produce today seafood, chicken, pig, beef, etc. It is still expensive, not very expensive, but with time in the coming decade, I think that almost everyone of us will eat these products.
Thank you, Gideon. Maybe you said you will speak a bit about Mashaf, and I think there are some questions here about how can the technology be adapted and or adopted in the different countries. For example, how can we implement solar irrigation in Nepal, for example, or in the Caribbean region? So maybe you can talk a bit about what we are doing about.
Yeah, what I can say is that solar, I mean, you have to adapt the solutions to the situation on the ground. I mean, it's not one fit for all. It's not one size for all. So I mean, if you are talking about small islands, so apparently solar energy will have to be very small scale, maybe on households. In Nepal as well, it cannot be, apparently if it's in the high mountains, it cannot be big fields. But big fields are being constructed in India, in China, in Germany, and in the United States and in other places. So you have to see the conditions on the ground. In some places it can be both. It can be the solar fields can be connected to the national grid or regional grid. In other places it can be completely autonomous grids, or even a grid of a few houses or one household. So one has to seek the advice of experts, and every case has to be studied. But I want to assure you that all the answers are there. It is being done everywhere in the world. It's not rocket science. It's only solar energy. Very simple, believe me.
Thank you, Gideon. Here, Dr. Binod Gupta is also talking about petroleum burning. He says it's much more severe than dairy farming, for example. We should have more discussion on petroleum burning. What do you say about that?
What I can say is that the quickest we move toward net zero, toward full mitigation, toward no more greenhouse gases, it doesn't matter from which source or resource, the better we will be. Every point on the scale, every degree Celsius counts terribly, terribly. We can compare the situation of our planet Earth to our body. I mean, in my presentations, usually I ask people if they have kids. And most of them tell me, yes, we have kids. And then I ask them, did you have a kid that had 40 degrees Celsius once? You know, his body heat was 40 degrees. Many of them, raise their hands and I tell them, how did you feel then? And they tell we were terrified. We didn't know what to do. Every fraction of degrees is dangerous. Exactly our planet Earth, every fraction of degrees bring us to a situation which is becoming more and more severe. So the most important thing that we have to do is to reduce emissions. Now, I know that many of the people listening to me are from developing countries, and the responsibility of developing countries to greenhouse gases is minimal, and the duty to reduce is mostly with the big emitters. But the most important things people can do, let's say in developing countries, is adaptation, and to adapt themselves and to prepare themselves to the eventualities of the climate crisis. And remember what I told you in the beginning. If you take one thing from my lecture, take the imperative to move as much as can, according to your conditions, to irrigated agriculture. At least this is my experience from Africa, because we will not be able to rely, as in the past, on the cycles, the natural cycles of the rain, of precipitation. It is changing. The climate is becoming more chaotic. And the way to produce is to be able to control the source of the water. The source of the water is the most important thing. If you control this, and you will be able to control most other factors that enable you to produce.
Thank you. Thank you very much, Gideon. Evelyn, we will, Gideon, thank you for an excellent lecture.
Bravo.
We have many, yes, bravo. We have many more questions, which we will try and answer by email. So thank you very much for using the chat. We would like to keep the timetable. So Evelyn, the floor is yours.
Yeah, thank you. I think we will give 1 minute to Giora to say hello to everybody.
So let's introduce Giora again.
Yeah.
Please, we invite Mr. Giora Tesler, Director of Mashav Center, MATC, to say some words on behalf of the Ministry of Foreign Affairs. Please, Giora.
Hello, how are you? My name is Giora Tesler, and I'm the Director of MATC, that's the Mashav Agriculture Training Center. I had some words to tell, but I don't want to disturb the lecture. So thank you for your participation in the webinar. The issue of climate changes is a worldwide problem, and especially in agriculture. It is essential to find tools to deal with it. Israel is one of the leaders especially in agriculture, has been busy in several years trying to find tools and to overcome this challenge. We succeeded, but we're still haven't finished the challenge. I hope that you will take what was said in the lectures and pass it to your own countries. And thank you, and may God bless you.
Thank you, Giora.
Galit, what do you say? Maybe before Gideon is leaving us, or Giora, maybe we do one group picture.
Go for it.
So please, if you can open your cameras for even 2 minutes, 2 seconds. Let's do an international picture. We are 144 people here in this webinar, in this meeting. So how nice. It's really an international meeting. So we want a smile. Are you smiling? Everybody smiling? So I think it's the time also to say shalom to those who came later. Next time, please, on time, okay? Okay, thank you so much, Gideon again, and thank you so much, Giora and Daniel, for your opening greetings. And we are going to our second lecture of today. And I am very honored to introduce Dr. Gideon Toporov. Dr. Toporov is the head of Climate Change Adaptation Desk under the Agroecology Department at the Ministry of Agriculture and Rural Development. In his capacity, he coordinates the ministry's task force for climate change adaptation in agriculture, being in charge of developing knowledge, informing policymakers, and training farmers towards sustainable and climate-smart agriculture. Additionally, Dr. Toporov serves as the ministry's co-coordinator of the Agricultural Preparation Committee on Climate Change and the National Greenhouse Gases Reduction Committee, led by the Israeli Ministry of Environmental Protection. I'm very happy to invite Gideon Toporov to share with us some of his experience on food farming in the light of changing climate. Gideon, the mic is yours.
Hi to everyone. I'm very honored to be here and to see so many people from so many countries, and also to share the floor with my namesake here, Excellency Ambassador Gideon Behar. My name is Gideon Toporov, as Evelyn said, from the Ministry of Agriculture and Rural Development. And I want to talk about 3 perspectives of food farming in the changing climate, talk about some challenges, hopefully some solutions, and I want to start with 3 pictures, I call them. The first picture on the left is a picture of past climate change adaptation in Israeli agriculture. And in short, this is a story of a quite young country, and already in the early stages decided that together with rain-fed agriculture, also irrigation is required to help to provide food security, and as a means to produce more food from our soil resources. And I'll tell you about a little bit about the story of how in an area of water scarcity, this country was able to cope and manage their agriculture. The second is about the current story of the climate extremes, climate change, and the very diverse effects and impacts of climate change, and the special sensitivities and challenges. And then the third is going to be looking into the future. And looking into the future, we realize that we can't bask in the success of the past, and also in the small solutions that currently being devised. We also need to look not only at solutions, but also at a whole change of our food systems. When we say food systems, we're referring to not only to the practice of agriculture, but to the whole system around food production. What do we eat? How do we eat? When do we eat? How is the food produced? How is it transported, and what happens to it at the end of its life? So that's the story of changing the food systems. But first, I'll start with an introduction to Israel climate and Israel agriculture. So, unfortunately, we were unable to have you as visitors physically in our corner of the world. This is the map of Israel, a satellite of Israel, and our agriculture is not very big. If you compare it to other countries, about 420,000 hectares of arable land, 150,000 hectares of pasture land. Of the arable land, about 3/4 is open field crops, and the rest of it orchards and protected crops, fisheries and livestock. Out of the plant agriculture, about 50% is rain-fed, and the other 50% in area. 50% of the area is rain-fed, not in produce, and a little more than 50% is irrigated. The soil resources, the land resources are not very big, and this is a graph of several countries in the world, and the available land per capita per person for growing food in Israel is relatively low, and a lot of our decisions, or what we produce and what we don't produce, derives from this fact. The climate, this is the map of Israel. Something disturbing me. This is the map of Israel, and if we take Jerusalem on this point of the map, we can see the temperature and precipitation. The summers are hot, the winters are cold, and the summers are hot and dry, winters are cold and time scale of precipitation. You can see on the left that there's a large geographical scale from.
We lost Gidon?
Yes.
Okay, let's see if we can get him back soon.
Well,
Hey, Gidon, we lost
Aye.
you for a few minutes, few seconds.
A few seconds, okay. I was worried that we missed the whole bit. Okay.
Continue, thank you.
So just continue from the same spot. Okay. So we can see here the precipitation grade along the map of Israel, from quite wet areas in the north and northwest to very dry areas in the southeast, and the same is if we look around the globe, we can see areas which are highly with high precipitation and low precipitation. And we know, of course, that the precipitation is only half of the picture. Together with precipitation, what determines the aridity is the other side is the evapotranspiration. Here you can see maps of evapotranspiration in the South Mediterranean, South and Eastern Mediterranean, current and future. So this is a very dry area, and it's going to become drier, as mentioned by Ambassador Gidon before. And this is a map that IPCC produces, IPCC, the Intergovernment Panel on Climate Change, showing an aridity index, which is the difference between the amount of precipitation and the amount of evapotranspiration. The more you have rain and the less you have evapotranspiration, then the water stress is lower and vice versa. So like I said, this is arid to semi-arid area, and it's always have we've always had water scarcity, and this is an optimistic story of how water scarcity was turned into water proficiency, because nowadays when we talk about climate change challenges for Israel agriculture, we're not so worried about the water perspective, but more about temperature and extreme climate events, and I'll explain why. So this is a timeline, a time scale of Israel as an independent country. In the first years, like I said before, there was an attempt to use more and more of the water resources for irrigated agriculture. This region has been from the antique region, which has been producing rain-fed agriculture. And the more we can use irrigated agriculture, there's a chance to produce more food and to help food security. And in the first decades, the water for irrigation was fresh water and was mainly surface irrigation. Here I have to mention the former head of our unit, the agroecology unit, Anat Loengard, who's the one who produced this slide and taught me and us in our unit a lot of what we know about Israel agriculture and climate change. So thanks to Anat. The next decades, 60s, 70s, beginning of 80s, are the time of introduction of changes in infrastructure. The main change is the building a national carrier to carry water from Lake Kinneret to other areas which have less water resources. A use of pressurized irrigation, metering and automation technologies, and this is the beginning of change in transport of water and more efficient use of water. And I also must mention legislation to ensure that the water is used duly and carefully. So a few photos from Anat and from Elisha Koenig, former extension service people. And this is different kinds of pressurized irrigation. Pressurized irrigation is much more efficient than surface irrigation, can just about double the amount of food produced from every drop. So this was instrumental in reaching or starting to reach the goal. Back to our timeline. So we add to food security in our time scale of adaptation to climate change, we add increased water use efficiency. Next decades, more and more use, on one hand, of drip irrigation to increase the efficiency of water use, and on the other hand, using more and more marginal water resources like brackish water and the beginning of the use of treated wastewater. So a few pictures about the drip irrigation has been mentioned before by Ambassador Gidon. Just a few pictures. This is maize irrigated with drip irrigation. You can see why would we wash the whole of the soil, the whole of the field, if we can only direct the water to the root zone of the plants, and this in that way we can use or achieve much more food for each drop of water. So this is a picture from the southwest of Israel. A very dry area, 200 millimeters of rain, maybe a little bit less, and now we covered them with the irrigation pipes, and now potato plants around the irrigation spots. And this is still desert area. You can see between the lines where the tractors drive, you can see the soil is very dry, but the directed water is enough for the potatoes to grow properly, and they have lots of examples of drip irrigation. I think that's a story that has been told already. 21st century has been characterized with more and more use of treated wastewater, and this is a treated wastewater treat facility producing water which is not good enough for drinking, but definitely good enough for using for irrigation. And there was a question before in the chat: is it safe? How about heavy metals? How about microbiology in the water? How about different micropollutants? So there is quite intensive regulation of the use of treated wastewater, and risk assessment in cases that it's too risky. We wouldn't use it for irrigating lettuce or vegetables, but we can use it for irrigation, let's say, of almond trees or olive trees. And the question is how you manage the risks and make sure that you have enough knowledge to understand the impacts of the treated wastewater for the plant health, for environmental health, and for human health. So I like this picture also from Anat. This is the Judea desert with a water reservoir, but not natural water. It's treated wastewater reservoir, and you can see in the background it's a very dry area, but near the reservoir you can see all these almond plantations, which are all growing on this treated wastewater, and next to it the signs showing that this is not drinking water. So managing to make the most of the non-drinkable water, non-potable water has been important to allow adaptation to climate change. And these are almonds again growing on this water. And the current step in our timeline is the increased, was mentioned before by Gidon, increased use of desalinated water as an extra resource used on the first try for domestic use, for industrial use. That's the first use of the desalinated water. But the desalinated water, after it's been treated, well, some of it's used also for agriculture, and even the reused desalinated water is also has lower salinity and is better for the soil and plants from the original original treated wastewater. So our treated wastewater based on desalinated water is becoming better and better for at least for our fields. No, this is the wrong one. Sorry. Let me run back. So this is what I meant. I meant to show an area photo showing the Hadera desalination plant taking water from the sea, and after taking out the drinking water, the sweet water, expelling of the brackish water back to the sea. These are the columns used with filters for the water, and from year to year we see an addition of capacity to desalinate more and more water from seawater to fresh water. And if we look at the global picture, on the left is the amount of irrigation in different countries in the world, from wastewater and treated wastewater. And Israel is not a big country, but one of the even in amount of water used, one of the main users of treated wastewater for agriculture. And on the right is the future water resources for Israel. 2010, we've been mostly using potable water for all uses, not for agriculture, for all of the uses in Israel. And our forecast is that by 2040, we'll be using much more water, and the water will not come from over-exploitation of potable water resources. It will be by use of new water resources, marginal water resources, and allow us to keep sustainable water systems, and even in the past few years build the infrastructure to bring back fresh water into our Lake Kinneret, which is our big water reservoir, freshwater reservoir. We are developing the infrastructure to direct clean water back into the Lake Kinneret and improve its quality, because over the years, over-exploitation has made Lake Kinneret's water a little bit higher in salinity. So in the next 2 years, we expect to see, we have tools to make it sweeter again, let's say. And important to say, this is the same time scale since the 50s to our times. Water for agriculture was the main use of water in the first years. In the blue line has been going down, bringing the green line down with it. Less and less use of fresh water for agriculture means less and less exploitation of, this is per capita. Less and less use of water per capita. And what's most important is, if we look at the crop index, the purple line is a crop index, and we're managing to derive a larger amount of food without increasing the amount of water, and using marginal water instead of fresh water. So that's what we call decoupling of the food-water axis. Instead of having to use more water to get more produce, we're getting more from less. So that is a story of taking water scarcity out of the climate change adaptation equation. And next thing I wanted to talk about is our current and very big challenges of climate change impacts. And we're seeing I think this probably won't surprise many people. We're seeing very diverse effects, impacts of climate change. If it's rain-fed, grown agriculture, we're seeing less and less rain in some areas, not all areas. But what's more important is, even if we get the same amount of precipitation, of rain, we're getting the same amount in less rain days. We're having more dry spells, and between them we're getting sometimes heavy rain, which is also not good for agriculture. And other in vegetables, we're seeing loss of quantity and quality of produce, and this affects also orchards, citrus, and livestock. And in a specific, if we were worried already before, we had in the spring of 2020 a very severe heat wave, which we hadn't been used to. And this heat wave, times where usually there's moderate temperature. We had over a week of degrees of above 30 degrees Celsius in the night and 40 in the day for a long time, which we hadn't had before, which resulted, non-surprisingly, in severe damages to food production. And we realized that we have to be more prepared to the extreme climate events, and specifically the changes in the weather. And these, I said before, the diverse changes of temperature to plant physiology and the produce. And one of the things we did was to try and have a wide survey of farmers and people who are in the agriculture industry in Israel. And we asked them 3 questions. We asked them what the main impacts of extreme climate events are. Are they practices or tools that they know of to combat the climate impacts? And are they barriers for implementation of these tools, practices, and technologies? So we're trying to build a wide knowledge base that will help us to direct our activities in the ministry towards combating climate change. And besides that, or as a drill down from this, this is just the way we see the results. This is the effects of various climate events, and these are the answers given by responders who are growers of apples, cherries, plums, apricots, peaches, etc. So generally, the way we look at it is, apart from the effect of lack of water, if you have enough water for your agriculture, how do you know what the effects will be on your produce? And obviously, it's different from plant to plant, from crop to crop, and it depends on your geographical area, and it depends on your vulnerability to the climate effects. Because if you're growing apples, which need a certain amount of cold in the winter, but you're growing it in a northern cold area, then the risk of your exposure to warm winters will be very, very little. So the way we look at it is to try and map our risks, looking at sensitivity, exposure, impact, and vulnerability. Sensitivity, and all data-based. Sensitivity, I mean, to map the sensitivity of the different sector-specific climate indices. Each each crop or each kind of agriculture is affected by different climate trends. Then exposure to identify climate trends and forecasts. What is the actual climate change expected? Impact. What will be how can we assess the risk or the damage of those climate events? And the last is the vulnerability. What can we do in the crop if we're seeing that we're going to have in the future more and more days of 45 degrees Celsius with the extreme heat? Do we have the means to protect our crops from this heat? So that's what we call the climate change risk assessment. That's one of the main projects. And on a few scales. On the farm scale, the challenge is to identify what the problems are, what the impacts might be, and search for solutions. But in the more wide scale, in the municipal scale, how can we take different farmers from the area and create a collaborative ecosystems which helps them to cope and manage the challenges? We can look at it on the national scale. How do these changes, how should the change drive and change policy making? And the last is regional. If in our area we're seeing specific climate trends, maybe the whole way we look at our food systems should be different. Maybe we need more land, more water, or more exports, or more knowledge in order to strengthen our food systems. And that's been looking at it crop by crop. And in next week, the meeting of next week, our agro-meteorologist Mark will be in this webinar and will tell us all about the risk assessment. So we'll be very interested, and you're all invited to listen next week, same hour. Solutions. We've been a few things points that Israel has been managing to do, or at least attempting to find solutions within livestock. Excuse me. Cooling systems for dairy cows. A lot of knowledge has been created, and it's been used not only in Israel but also in other by Israeli experts in other countries around the world. A lot of use of netting in orchards. These are banana orchards, and over the years we have found that the netting allows more water efficiency, and also less damage from extreme winds and from hailstorms, an increase in yield even if we don't have these weather events. So at the beginning, the government has been supporting farmers to purchase these nettings, but with time they've seen that it's worth it for them, and they're doing it from their own, even without support. And there are a few examples of different solutions, not exclusive to Israel. Some of them have been used in other places also. One that's important for me to mention is the use of genetic resources from the wild plants, and this is one of the focuses of the Agriculture Research Organization, which is part of our ministry, is building a gene bank and taking as many plant species as possible, especially endangered plant species, maintaining their seeds in a gene bank safely, and apart from looking after the ecosystems for natural reasons. We see this also as a resource for future development of varieties using these genetic resources. So, taking us into the future, and how will our food systems look in era of climate change? So when we talk about climate change, we must mention, we're talking about the role of agriculture in greenhouse gas emissions, and agriculture could be instead of being, as it is now, part of the problem, agriculture can be part of the solution, because agriculture, apart from emitting greenhouse gases and causing climate change, agriculture also creates opportunities to I'm looking for the word, but to take greenhouse gases, carbon dioxide, and even nitrous oxide out of the atmosphere, and mitigate the climate change. There's the adaptation challenge that I've talked about, and we have to admit, in some cases, it's impossible to mitigate all of the risks to crops, and sometimes there'll be loss and damage, in which case we want to assure the farmers that they have they can go back and depend on the country to help them with the insurance schemes. And one of the talks in next week, in 2 weeks' time, will be by Dr. Muammar Khadijia, who is an expert in insurance, agriculture insurance scheme, and is directing the insurance programs in our ministry. So in short, because I see we're running late, in MAD, in the Ministry of Agriculture and Rural Development, in the past, in 2021, has been established a climate change adaptation committee, and the committee decided that the objectives will be 4: risk assessment, assess risks of climate change, build climate smart agriculture, build a climate smart policy, and take into account the changes expected from climate change to the world of pests and disease, which are also influenced by climate. So just a quick word about greenhouse gases. Well, the main greenhouse gases that come from agriculture are carbon dioxide, methane, and nitrous oxide, and the various agriculture practices, including the sometimes lands which used to be natural habitats and are turning into agriculture areas, use of the waste from agriculture, burnings in agriculture, the agricultural tools and the agricultural practices, the livestock are all creating greenhouse gas. And we know that from research being done that about between 1/4 to 1/3 of the greenhouse gases in the world are attributed to the food systems. And there's been research looking into what strategies could be taken. And this specific paper from Science Magazine showing that if we look at the business as usual expected increase in greenhouse gases, it could be it can be nullified if we use plant-rich diets, healthy calories, high yields, if we manage to halve the waste, increase the agriculture efficiency. All these together can bring us to a state that we can reach zero or net zero emissions of greenhouse gases in agriculture. And That's one of our work groups, is focused on all of these attempts to grow more with less, which is what we talked about. It use water efficiently, use nutrient management precisely, protect natural ecosystems. I'm missing something here. Sustainable livestock, manage our waste, and these are all the ones in blue are in the agriculture systems. And in the domestic, the way that we our diets and the way that we use our food, plant-based diets are more healthy for the environment as well as for us as consumers, and also minimizing waste. Organic waste from our homes is also another important mission to reduce greenhouse gases. So I think this is the last. I think this is the last slide, or one before the last. When we try to combat and adapt to climate change, we're looking at generally we're looking at this. In cases that there are solutions and we know about the solutions for climate change, we're looking at farmer support schemes like in this pepper greenhouse, support to farmers for netting and protected crops, and also cooling systems for livestock. In some cases, the farmers don't have actual usable solutions, in which case we're looking at applied research, like in this example, avocado trees, which need the netting to protect them from climate impacts, but on the other hand, they need the radiation at different times of year and sometimes even different times of days. So applied research to produce systems that you can have flexible netting that can be taken on and off easily and automatically. Basic research, producing better varieties of crops and of trees, and even new crops like quinoa in this photo. All of these together are supposed to help us combat climate change effects. And in the case that none of these work, then we have to support the insurance to allow the farmers enough trust in the system so they can grow our food. So like I said before, our objectives were to assess risk to climate change, to devise policy, to find solutions for climate smart agriculture, and to understand better the effects of climate on pests and disease and mitigate new pests. We have several working groups to reach these objectives, and over the past few years, some achievements and some the achievements are in white, and the gray rubrics are still in work, working on agriculture models of risk assessment, economic models, trying to move on to cost-benefit assessments of climate change adaptation measures, devising policy for greenhouse gas emission reductions or better balance between of greenhouse gases. We're working on food security policy, which is not only our ministry, but together in collaboration with other ministry, supporting agriculture insurance programs. We have new schemes for applied research and also new research centers and funds for climate smart agriculture, and hoping to soon have new farmer support schemes, and the pests and disease protection, trying to improve the pest risk assessments and include climate change in these assessments, improve the monitoring of pests across sectors, and applied research to teach us of future pests and disease in an era of climate change. So that's all from me for today. Thank you very much for listening, and I'm open for questions.
Thank you, Gideon. I see some questions in the chat box. Gideon, how do you involve venture capital and accelerators to invest into agri-food tech startups to upscale research and technology innovation?
Very good question. Well,
One second,
obviously,
Gideon. One second, Gideon. Can you stop sharing so we can see everybody?
Yeah.
Thanks.
Great.
okay. So thank you for the question. So obviously, we need, as much as possible, we need the industrial sector, and it's always been part, as in developing irrigation technologies and climate technologies and automation technologies. One of the things we can do is collaboration between the agriculture research, the extension service, and the companies, and the farmers. We see it as one of the main. I'm part of the extension service. We see it as one of the main targets of the extension service is to lead to better cooperation between all the different stakeholders, and we have many examples of solutions which have been devised using these collaborations.
I think it would be interesting because there is another question about how you encourage very small farmers to introduce new technologies. Maybe you can give some examples, Gideon.
Okay, so it's always the biggest challenge. It's always much easier for the big farmers, for the cooperatives. It's easier for them to find the scientific solutions, to form collaboration with researchers or with other companies. So I don't have any magic trick or magic answer. It's only hard work. It's in the extension service over the years we've had dedicated more and more extension people to the smaller farmers in Israel. It's more the villages, the moshavim, and less the cooperatives. So we have specific people who defined as call it smaller farmers, work with smaller farmers, but it's always a challenge.
Thank you, Gideon. Yeah, I also think the extension service, it's the key of the success.
Yeah.
There is a question from Ludmila here. First of all, she says thank you for the lecture, and there are a lot of words of thank you. Do your working groups deal only with risk assessment or also with the risk management?
Okay, good question. So the risk assessment is a separate initiative, and we see it as very important in two ways. Risk assessment is important to inform farmers, and risk assessment is important to inform policymakers. Now, after having said that, risk assessment does not help the farmer to challenge the hailstorm, which is going to happen. So again, I think the collaboration between farmers, extension, also some companies like irrigation companies, pest management companies, nutrient fertilization companies, etc., and obviously researchers, because they are the ones who can bring in new solutions and help a lot of people at the end.
Gideon, thank you very much. I think we are on time, no? We want to be...
Almost. It's a Latin American time, Evelyn. I
I'm
think we can
sorry,
conclude.
I'm an Argentinian one. Yeah, sorry. Okay, so I think we will give a big thank you to Gideon, and thank you also to, we had 2 Gideons today. You will think that's the only name in Israel. No, we have more names. So thank you for Gideon and Gideon. Galit, thank you for this partnership. And Daniel is also with us, so thank you. Dear friends, thanks to you all for joining us today. We have a next meeting next week, Wednesday, 10th of April, at the same time, in the same place, for a second interesting session. Everybody invited. The same link, those who have already registered, you don't have to register again. I want to share with you our Facebook address and YouTube address in the chat. In the Facebook page, you will find, we will promote the second session there. Also, you can share it with other colleagues. In the YouTube page, we will publish the videos of the meetings, okay? And well, thank you again to everybody. Wish you a super great day for those who are still in the morning. Good evening for those who are like us, more east or more east than we are. See you next week, and hope for good news for everybody. Thank you again.
Thank you all. Thank you to Gideons. Bye. Thank you, Evelyn.
See you next
Bye, everyone.
week. Shalom.
Thank you. Bye.
Shalom to everybody.
Bye. Bye-bye.
Bye.
Good job. Good job.
Thank you.